Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 4. There's going to be 2 videos for week 4. This is the second video. This is on unit testing frameworks, in particular JUnit, and how to use this in the project. So first of all, let's talk about what's the meaning of software testing. Well, first you should know that you could have an entire course on this topic. So we're gonna brush over very quickly. So I'm just gonna, for those of you who are not well versed, I might say, in software testing, just gonna give a very brief overview of what that is. So essentially, when you do software testing, what you want to avoid is failure. So when you talk about testing, there's always terms or terminology that is involved. So that's a little bit of what I'm doing here, presenting the terminology and the concepts involved. So what you want to do is avoid failure. So what is failure? Failure is, well, anytime something fails, if you want to fix it, you have to do some kind of root cause analysis of what is it that caused the failure, because what you observe as a failure is some kind of symptom. Okay? There's something you observe that tells you that there was failure in the execution of the software. Now, this is by observing the symptom or a series of symptoms that you can actually analyze the behavior and then the code, and then be able to point out this is the cause of the problem, or often there's many different causes or a combination of causes, different faults in the software that are the cause of the failure. Okay, so this is basically when you debug software, you're doing some kind of investigation. Okay? You have some symptoms, some things that you see, and then it leads you to come to the conclusion as to where is the problem, and then you fix the problem. So first there's a failure. Failure is caused by a fault. And then as you see a failure, what you see, you don't see the cause, you actually see a symptom. Symptom being an observable behavior. Now, that's what we're going to do when we do the unit testing in particular here. We're going to actually force the observation of a certain behavior, or in this case, misbehavior. Okay. Because that's one of the things that's important to realize about software testing is when you test, as Esker Dijkstra said very wisely, testing can reveal only the presence of faults and never the absence. So anytime you implement a test, especially a unit test, you're trying to force the software into some kind of error. And what you want is that you prove somehow that this error is not there, that this fault in the software does not exist. So what you want to do when you do your unit testing is you want to have as many proofs as these as possible to somehow be to a certain level of confident that there is no fault in your system, that your system will not fail when it's actually used. Now, you can never be sure at 100%. Okay? The only thing that your test tells you is for each of the different cases that you have tested that this fault is not there. It does not tell you anything about the potentially thousands of other ways that it can actually fail. Okay? In the project, I'm going to ask you to have dozens of test cases. That's not very much compared to what it should be. If you would want to have a very thorough testing, sometimes you need hundreds of test cases. So this is also, of course, linked with the notion of debugging. So basically, debugging is fault identification and then followed by fault correction. When you enter a debugging process, it's generally that you observed a certain failure. the software is not working as it's supposed to be, then you do fault identification. So you try to find having observed the symptom, which is a symptom of a failure. You then try to find the fault in the code that caused this failure. Okay. That's called fault identification. Then once you have identified where is the fault, for example, what's the line of code that is wrong, or a combination of lines of code together that result in the wrong behavior, then you can actually fix these lines of code to make it to make the failure go away. So that's fault correction. Of course, debugging and testing is heavily related. What you want to do when you do unit testing is to avoid bugs and avoid that you have to do fault identification and fault correction. So software testing in practice is about identifying a certain possible system failure and design a test case that proves that this particular particular failure is not experienced by the software. So you see that it's a one-by-one basis. And we all know as programmers that for any program that you write, there's so many different ways that it can actually misbehave. Okay. And it's very difficult, as thorough as you may be as a programmer, it's very difficult to avoid all the bugs. A test case, especially a unit test case, is some kind of proof that a particular bug is actually not in the software. Now, going further in a more broad definition of what are the different kinds of test cases, testing methods. So there are different sources that you may use to do software testing. So for example, you might have requirements-driven testing. So you may have a set of requirements expressed by the user. For example, using use cases. User tells you, okay, if I want to achieve X, then I have to do all of these steps here and I get result Y. Okay. So then I can actually exercise the software, for example, automatically and prove somehow that these scenarios are correct, that these scenarios execute correctly. So that would be requirements-driven testing. You may also have structure-driven testing, whereby you would know what is what is the different components of the software down to the actual units. So you test all the units, combine the units together to form components, you test the components, you bring the components together. So basically you test the software from a structural point of view. The method of testing has to do with the structure of the software in this case, which is not the same thing as requirements driven. You may also have statistics driven testing, whereby you may, for example, test the software in a certain configuration or a certain load, and then you compute certain formulas that are expressing under which circumstances the software could be executing, and then imagining some statistics or taking some statistics from real life of another system, and then actually putting the software under the same statistical circumstances, and then see how it behaves. So the driver of your test here is statistics. You may also have risk-driven testing, where you imagine certain circumstances, exceptional circumstances that the system might be put in, and then you actually design a test that puts the system in a certain dire circumstance and see how it reacts. Okay. You have lots of different ways you can actually do testing. There's lots of different testing approaches using different sources as an input for the method that you're using for testing. So there are many levels and kinds of also software testing. There's unit testing. This is what we're going to do in the project. Have integration testing, which is somehow what I was describing in structure-driven testing. Function testing is essentially functionality testing, which has something that's related to what I said as requirements-driven testing. Acceptance testing is taking the system at the client's site and under the configuration of computers that is at the client site and actually running the software on the actual computers where it's going to be executed, which might be different from the computers where the software was developed. For example, in software development companies' computers, which might be different from the client's computers. And then you let real users actually use the software. So you see that depending on what phase in the development, you might have different kind of testing also. So what we're going to do here, we're going to concentrate only on unit testing. So unit testing is about what is a unit. A unit is essentially, in our case, for if we're using Java, a unit is a method that we want to test, a specific method in a specific class. Unit testing, what it does is that it sets a certain context in order to eventually call a method with certain predefined parameters. And then given the context of execution and the parameters that you give to this method, you should be able to predict what's going to be the output of this method. So you check if the expected output is the actual output that was given to you by this method in this particular context, given these particular parameters. With some kind of proof element that tells you, if I put this function in a certain context, you want to prove that it's not going to misbehave. And then you do this for example, for all your units, for all kinds of different contexts, for every unit, for every of your classes and so on. That's why if you want to do this thoroughly, you end up having hundreds of test cases. In our case, in the project, I'm going to expect that you have several dozens of test cases. If you want to do this effectively and efficiently, you need to use automation. What is called a unit testing framework allows you to have a very well structured way of doing this, to organize the tests themselves in a structured way and to execute automatically the tests. Okay. So that's what is a unit testing framework doing. Provides you with some kind of infrastructure to organize your tests correctly so that they map with your code correctly. And then it also provides you with a mechanism in the framework to actually automate the execution of all the tests or a portion of the tests. There are some things that unit testing framework cannot do or should not be used to or for. So you cannot expect, for example, that unit testing can be used for functionality testing. So unit tests are not made to, for example, test if a certain, as I was saying before, requirements-driven testing where you have a certain use case, and then you, for example, you simulate that the user is or using the software using a certain use case, and then the system would react in giving you a certain answer at the end. Why it doesn't work for unit tests? Because even if a scenario, a use case might be very simple, most scenarios would actually involve many different units working together. Unit testing is meant to test one specific unit. Okay. Other things for which it doesn't work very well is when you have user interaction. So user interaction, involve what you want to do with a unit test is that you want to predict very specifically what is going to be the context of execution and what are going to be the parameters. So it's something that's very deterministic. Whereas if you require user interaction, then it depends on what the user is actually going to do. So unit tests are not very well adapted for that kind of thing. All this to say that yes, unit testing is very good, but it's not good for everything. So what is unit testing? So a unit test is a piece of code, first of all. So very important in the context of this course. What I want you to concentrate, or what we are concentrating on in this course, is code. That's why I'm not asking you to produce documents. I'm not asking you, there's no design issues. Yes, there's design involved in coding, but I'm not asking you to write design documents and so on and so forth. So in this course, we're concentrated with code. Yeah, unit tests is a good example of that. A unit test is actually a piece of code. A piece of code that you write to actually exercise another piece of code. Okay. So yes, the unit tests that you write are code. So it's a piece of code that you use to exercise another piece of code, and it would exercise a particular method in a particular context. So that's as how we will see after. The way a unit test is organized. First it defines or sets the context that is necessary for a certain method to be executed. For example, you might execute a method, and then this method, it may actually use other things than the actual parameters that you're going to pass it. For example, a method may be using a global variable. So if you want to exercise this method that is using a global variable, you not only have to pass it parameters, you also have to set this global variable. Okay. Of course, a method is part of an object. An object might be part of a group of other objects, need to be part of a group of other objects in order to achieve their work. So any other object that this object that you are testing depends on for their execution, you would have to set it up as a context before you can actually start the execution of this method in this object. So unit test is always, you set up a certain context for this object to be properly working. Then you take one of their methods and you pass it very specific values. Then you would expect that it produces a specific value in output. Then you check if this value is in fact what it gave you as output. And if it's not, then your test failed. If it is, then your test passed. So the goal of unit testing is to isolate important parts or units of the code and then test them thoroughly. Okay. And that's one of the things that is somehow difficult, is to identify what are those units that are important. Okay. Of course, if a certain method is executed extremely often in the execution of the software and in a lot of different contexts, then it's good to actually test this method, because much of the execution depends on very often the execution of this method. There might be also some other method that, if they misbehave, would actually have a disastrous impact in the execution of the rest of the software. Whereas there might be some methods, even if they fail, doesn't change very much the whole execution. So there are some critical methods in your software. So it's up to you to, if you want to concentrate your efforts in unit testing, you have to identify those units that are critical in the software, which is not an easy thing to do. So you might ask also, why am I not just saying I'm going to test everything? Well, because there's way too many things to test. Okay. And you don't want to invest testing effort on something that is almost never used, or a method that is almost never used. So you want to concentrate on things that are crucial. So what are the benefits of unit testing? So as you have tests that you can execute on a certain method, it's some kind of a proof that the code in this method is working correctly. Now, after it's been tested, you might say, well, why do I need the tests after I've proven that it works correctly? Well, very often, and especially in incremental software development, the code will change, as we saw repeatedly now in this course. So the code will change. So as every time it changes the code, you run the chance that you will break the code. So if you have a bunch of tests that are meant to test a certain method, and then somebody goes and changes this code, then if you have tests for it, then you can run the tests after, and then you can see if you actually broke the code by changing it. Okay? So it's a way to actually facilitate change. Because what's difficult sometimes when you apply changes is that you introduce a bug, then you might not see right away that you introduced a bug, so that if you encounter the occurrence of the bug a few days after, you might not remember what changes you made that actually caused this bug. Then debugging will be taking you a few hours, you lose time. As you take time to debug, you're not writing new code. You're not being productive. So you want to make sure that as you make a change, make the change in the code, run the test. If you did something wrong, boom, it tells you right away. And you know exactly, because you change only one line of code, you run the test fails, then it tells you exactly where the problem is. You can fix it much more effectively right now, as you know exactly what's the cause of the problem. So having unit tests actually facilitates changes. Simplifies integration. One of the things when you do integration, when you want to integrate things together, one of the things that's happening is that as you're designing a certain class in isolation and you provide some features that this class is supposed to provide, then you're designing the code according to what you think you know that this is supposed to be doing. Now, somebody else might be designing another class that is eventually going to use this class you're designing now. Now, there might be some ways that this other person is trying to use this class you're doing now that you did not think of as you were designing it. So so maybe it's gonna work correctly, or so you think from your own perspective when you do it, but when you're gonna put these two things together, this other piece of software, this other class is gonna use your own class in a way that you did not expect. Okay. So the point is that the more you design test cases about a certain unit, the more you force yourself to analyze all the different ways in which it may be used. So this, by forcing you to think about how it could be used, it will force you to, ask around how other people think that this class that you're doing right now should be working. So if you have the tests as you are developing the class, if you're designing the tests and you make them according to what is globally understood as to how this unit should work, then it will make it less probable than when you combine things together or integrate them that they will actually fail by integrating them. So it simplifies integration. Documentation. So I'm not talking about here Java doc or things like this. What I'm talking about is that when you actually test a piece of software, the unit tests that you have, they're essentially a procedure that are showing how somehow all different kinds of ways that this method can actually be used. Every test case that you have that test a specific method, somebody is reading the tests that test these method. It's telling them a lot about how this method is supposed to work. Okay. So just reading the tests gives you a lot of information about the nature of what is being tested. That's why it provides you with good documentation, with information about this, the units that are being tested. Another benefit, distribute the feedback. So we talked about that in a previous lecture. The idea of distributing the feedback is that you want to get feedback as to, what can be wrong about this software that you're building. So for example, you want the client to be exposed to your solution. So the client tells you as often as possible, what are the things that the client considers is wrong, so that you don't receive all the feedback, for example, at the end, before, or as you're deploying the software. Okay. So you want to distribute this feedback over time, so as smoothly as possible, you can solve the problems, as they are uncovered over time. If all the problems are uncovered in a very short time frame, for example, at the end, then all these problems are going to be conflated, and it's going to be very difficult to solve them all at the same time, or as in a bundle. Okay. What you want is to uncover these problems as you go and solve them individually as much as possible as you are going, to avoid that they are bundled in a very short time frame. That's what's happening when you have the unit test cases. As you're doing your development, you should develop your test cases as you're developing the code, so that as you're adding new code and you're changing code, you can run the tests, so that as you make a change, you develop a certain class, you do the test, you run the test passes. And then the day after, somebody comes into your code and then changes something in the code, then they can run the tests and then see if they broke something. If they broke something, it's going to tell them right away, then you can fix the problem. So as the more tests you have, the more people will be made aware by the tests that they actually made a mistake. So that that will eventually distribute the feedback over time. By the more tests you have, the more unit tests you have, the more it's going to distribute this feedback over time. And it's going to be less of a magnitude of problem by realizing the problems all at the same time as you, for example, turn the switch on as you are delivering the software to the client without having tested it, which is, of course, something you don't want to do, but that is unfortunately sometimes happening. Build confidence. So of course, it's important when you're doing something difficult to have some confidence about what you are doing or what you did up to now. We all know as software developers that sometimes as you compile the code, yes, it tells you that the code compiles. You as the developer, the programmer, might test, you try to use the software, but we all know as developers that the developer using the software and the client using the software, you are not going to use the software in the same way as the client will. So that, so there's a certain confidence building involved in having tests. So it forces you to exercise the software up to a certain extent as thoroughly as possible. Okay. So it gives you more confidence that the software has been thoroughly tested. Also, if you change something, you run the tests, and the tests tell you the tests are not failing. It gives you some confidence that you did not break something by making a change. Of course, it's possible that you would have broken something that was not tested. Okay, so there's a limit to this sense of confidence. It's always a false sense of confidence anyway. What I mean is you cannot test something for 100%. You cannot test for 100% of the bugs in a program. And as I just explained, also it forces you to analyze different ways that the software or the methods or the units can be exercised. As a coder, very often you have kind of a preconceived idea of what a method should do, but sometimes there are some combinations or different paths that can be taken in the method that you did not imagine, or a certain combination of parameters combined with the context that you did not imagine. So designing unit tests actually forces you to think of the unexpected, maybe. Okay, so what is unit testing framework? So for the larger is the system and the more complex is the system, the more units there are, eventually you can end up necessitating having thousands of unit tests. That's not an exaggeration, let's put it this way. Now, the thing is that if you don't have a way to automate the execution and the maintenance of these tests, it can be a very costly experience to run the tests and also maintain the tests themselves. Okay? That's why you need a tool to automate this procedure. Okay? So, eventually what you want to achieve is the efficiency of running the test, efficiency of maintaining the tests. So you need a tool that provides you with efficiency and automation. So essentially here we're talking about unit testing framework. Essentially we're talking about here a specific kind of unit testing framework, which is called the XUnit testing framework. So this is a testing framework for object-oriented programming. So in this case, what you do is you associate classes and methods to corresponding test classes and test methods. So if you want to test a certain class, you have the class. This class has certain methods. If you want to test it, normally what you do is you design another class that is the test class that is going to test the tested class. And then this is a class, and then each of the methods in the class are going to be a test method that is going to implement a test case that is going to exercise one of the tested methods. Okay, that's the general concept of a XUnit testing framework. There are other kinds of frameworks. That's here what we are talking about. So automation is achieved automatically by setting up a context and then calling each test case and then verifying for each of the test cases, the running of each of the test methods, if the tested method is returning the right value given a certain context and a certain parameters. The unit testing framework will actually automate the execution of all the tests. Okay, so that's one of the things that this framework is doing, and that's absolutely necessary if you have like thousands of test cases. Of course, then these test cases, these test classes and test methods are code. So you can actually combine that with the use of a software versioning repository. So you submit, you commit. Basically your unit tests are part of the code, development code. It's not something that you would deploy, but it's something that's part of the development code. So you can actually store it into the repository as you're developing the code, so that you share your tests also with other developers as along with the code that you're developing. One of the things which also, as I mentioning here, so one of the things you can achieve also is that as you are committing code or pushing your code onto the repository, There's also ways that you can automatically run the tests as a commit is pushed onto the repository. That's one of the things that I'm introducing in this semester here that I'm going to expect that you are doing. There are lots of different solutions that you can use for that. If you go in the lab instructor will show you a couple of different ways you can achieve that. So as I mentioned, so what are the components of a unit testing framework? You have a tested class, so that's the class that you are testing. Then inside of this tested class, there is a tested method. That's the specific method in this specific class that you are exercising using a test case. The test case is the procedure that you use to actually test this tested method. The test case is some kind of procedure that is implemented in the test case method in the test case class that you are writing in the JUnit as a JUnit class. So your JUnit class, in your JUnit class, you write test case classes which contain test case methods. Each test case method implements a test case that is exercising one of your tested methods. Then you have the notion of a test suite, which we'll see at the end of this lecture. The test suite is essentially a way that you use to group a subset of your tests or the entire set of tests that you have. So that if you may want to, for example, you may have 1,000 test cases to run, it would be inefficient for you to actually have to run all the test cases every time you make a single change in the code. So what you may want to do is to create subsets of test cases so that if you change something, for example, in this module here is composed of by a reduced number of classes, then you may have a group of test cases or a test suite that is only meant to test this module here. So if you make a change in this module, you only run the test for this module because you didn't change anything else, so you don't need to run all the other tests. So test suites are important to actually optimize the time you spend in running the tests. Imagine you have thousands of test cases. It may take several minutes to actually run all the tests, or even maybe longer. So in Java, the standard unit testing framework is known as JUnit. There is XUnit testing frameworks for almost, I would say, every object-oriented programming language. For Java, it's called JUnit. In this case, the test cases and the test results and the test methods, they are essentially Java objects. So essentially, JUnit is implemented as Java. Okay, it's the same language. Your unit tests are written in Java. So JUnit was created by Eric Gama and Kent Beck. You might remember this name when we talked about extreme programming. We talked about Kent Beck. Yes, that's the same person. Kent Beck is the initial designer of the notion of XUnit testing framework. For those of you who know design patterns, Eric Gama is one of the first persons being well known to develop the initial design patterns. So these two persons came together to actually design JUnit, which was one of the, I think, was the first XUnit testing framework, which was then applied to other languages. The same concept was applied to other languages. Okay, so using JUnit, you can actually, it allows you to write some tests as you go. As you design some classes in your code, then you design the test cases that go to test this code that you are building. Then forever after, if you change this code here, you can run the tests. That's basically how it does. That's how it's meant to be. Okay. A lot of people would develop all their code, and then right before it's being delivered, then they think, oh, I'm going to write all the tests and then run the tests and then somehow prove that my implementation is correct. Wrong. This is the wrong way of actually using JUnit or unit testing, especially in the context of incremental development. You want to have your tests done as the code is done, so that as you make changes to the code, which is happening very often in the development, every time you change the code, you run the tests. Okay. If you do your tests only at the end, you don't have them to actually test the code as you develop and as you make changes. So what's the procedure to actually write or come up with and run your test cases? So first, I already mentioned that. So first you set up the context in which the method will be called. So as a method is executed, yes, you pass some parameters to this method. That's part of the context. Very often, that's not all there is. This method is part of an object. Often this object, as you execute this method, this object is meant to be connected with other pre-existing object in order to execute correctly. If this object to which this method belongs is requiring other objects, this becomes the context that you have to set before you can call this method. Okay. Very often the context will be something that's very complex to set up. Okay. Sometimes people figure out that if you're trying to test a certain method and then setting up the context is extremely complex, that somehow tells you that the design is overly complex or should be simplified. So sometimes the process of writing test cases, if writing test cases is difficult, it tells you that the code, maybe the code should be refactored or reorganized so that it's easier to actually test them. Okay. So first, setting up the context. Hopefully that's not too difficult, but sometimes it is. And then you call the method. Of course, by calling the method, you must determine what are the parameters you send to this method, if this method has parameters. Then, of course, you call the method, it's operating, and then it's returning a value. Okay. Still possible to test, to do a unit test on a method that doesn't return a value if it has some side effects that you can observe. But of course, it's much easier if you can observe the result, which is the value that is output or returned by this method. So set up the context, call the method. You should have determined what is the correct behavior so that you can actually check after if the correct behavior is observed as a result of executing the method. And the way to check this is to use what is called JUnit Assertion methods that allows you to check if something, for example, if something is true, if something is present, or if there was an exception that was thrown or not, or to observe something that some kind of symptom that you can observe that tells you, yes, this method executed correctly. So you would use assertion methods to assert if the method ran correctly. So this I already mentioned. So the context, so you have to set up the context. The context can be represented by, of course, the values passed to the parameters of this method. It may also be that this method is using global variables, in which case you have to set their values. It's possible that this object requires other objects to be existing before you actually call the method. So in which case you would have to create them before you create the object, before you call the method. So yes, setting up the context can be difficult to figure out what is the actual context, and then the context might be, there might be numerous objects to be created. And then you pass the actual parameters to the function, and then you then observe the actual result. Now there is possibility there when you set up the context. There is different ways you can actually achieve that, because it's possible that in your test class, for example, you may have 10 different test cases in a test class that are, for example, testing this method. So you have a method that you want to test, this method here. And then you design a test class that is, so that's your tested class, and that's the test class. So it's possible that when you test this method here, that you want to test it using a lot of different test cases, which are all one different method in this test class. So all these methods here are exercising this other method here in a different context, expecting different values in output. So it's possible that all of these methods here that you are executing, they have to set their context. Well, it's possible that they are all using the same context. And it's also possible that as you execute each of them, so you have to set the context and then you execute this method here. It's possible that the execution of this method will change the values that you had set in the context, basically altering the context. So that after this method has run, you cannot use the same context anymore because it has been changed by the first method. Okay. So then you would have to reset the context to the initial context before you run each of them. Okay. So there are some methods that you can define in JUnit that actually allow you to set the context to a specific context before you run a certain all the test methods inside of a certain test class. So there are different, okay, so here I'm introducing different versions, JUnit 3 and JUnit 4. And what you have at this point in time is JUnit 5. The fact of the matter is that JUnit 5 is very similar to JUnit 4, but JUnit 3 is kind of different. So why am I showing JUnit 3? There's a lot of JUnit 3 test cases or code that is out there, so you might see it. You might have to deal with JUnit 3. So let me concentrate with JUnit 4, as this is what is more common nowadays. So this method that I'm talking about, essentially you would write a method in your test case, in your test class. That is the method that is to be executed to actually set the context before every of the methods is actually executed. So if you have such a method that sets the context before every method or every test method, then you would actually write this method and then precede it by @before. So any method that is preceded by @before in a JUnit class is a method that is going to be executed before all the test cases that are in this test class. The same thing is for @after, except in reverse. So @after is a method that would be executed after the execution of every of the different test methods. Again, you would use that if in your class all the methods are actually sharing exactly the same context that you want to reset every time the next test case is to be executed. There is this, again, the same concept, except that if you have a certain context that is like global to all the test cases. And that is, it doesn't matter if it's being changed by each of the test cases. So you may want to include the setting of such a context into a method that is preceded by at before class. So the at before class method or methods would be executed before all the test cases, but only once before the first one. Okay. Whereas at before is re-executed before every of the test cases. You don't need to have at before and at before class, but sometimes it might be useful in order to kind of factorize your code. You don't want to, if you don't use at before and you share the same context across all the methods, the test methods, then you would have to repeat this code over and over again, each of your test methods. Basically, you don't want to repeat code. You basically factorize it and put it into an at before method. Now, what about the assertions? So I'm not going to go over all of them. So I'm going to show some examples of them a little bit later. So there is plenty of different assertions. This is how you actually have the unit test to actually either pass or fail. So you make it call one or more of these assertion methods, and each of them will check for a certain condition, depending if the condition is true or false, or is some of them are also checking for example, exceptions. So if something is a certain state is in the expected state, then the assertion will return true. And if it's in the unexpected, or it's a different value or different state, then it's going to return false. Okay. So any test method that you write should have at least one assert. Okay. If you write a test case and doesn't have any assert, it's not a test case because it does not exercise anything. Okay. So any test method should set the context, call the tested method, and then do some asserts that are testing whether the state after the execution is the desired state. So here's an example. So here, this one is in JUnit 3. So here in JUnit 3, you write your test class here. And then, no, this is JUnit 4, sorry. Yeah, well, this class here is misleading. It's called JUnit 3. It's just my class happens to be of this name. So in JUnit, this is a JUnit 4 test case. How do you know? Because it has the at test. Anytime you have at test before a method, this is actually a test case, a test method. This is one of those methods that's going to be called when you trigger the execution of the test cases. And then in JUnit 4, your classes don't have to be a subclass of any other specific class. Essentially here, I have one single test class, and it has one single test case or test method. And then it does set up a certain context, and then it does something, and then I'm checking if the result is actually correct. Okay. Note that here I'm having many different asserts in the same test. It's not necessarily advisable to have so many asserts in the same test. What you want to do is to separate them so that if one of them is failing, it tells you exactly what is the reason for the failure. Okay. And then this is showing the interface when you use Eclipse. So in many of the IDEs, or most of the IDEs you have nowadays, will have plugins for already implemented for running JUnit. So this is how it looks in Eclipse. So essentially you run your application as unit test, And then it actually starts this here and then runs all the tests. And then it gives you some report as to how many tests there were, how many failure, how many, basically, if the tests pass or fail. This is here another example showing that you can have different classes, but that you can also have, like, for example, here, I'm setting a certain context, and then I'm having different test cases. Then if I want this context, the problem here is that this context is set as the object is created, then I run this case here. So if, as I'm running this case here, I would be doing something that changes this context here that I've set, then the context would be changed when I execute the further methods here, further test methods. So if I want to make sure that my context is reset every time I execute a new method, then I would actually put this here into an @before method. This way, if I run this class here, then it's gonna run this method here before it runs the test here. Then it's gonna, before running this here, it's gonna run this before again. So that's resetting the context and making sure that it does not been altered by the previous test methods. So that's what's the use of @before. So here I'm introducing an example class. So here I have my tested class. So here I was basically testing something very simple. So I was testing essentially that my string operators were working correctly, or that string objects were working correctly. So here you might say my tested class was string. Of course, very often what you want to do is to test your own classes. So let's say this is your own class. So it has one data member string, and then it has 3 different methods. Okay. So this is essentially my tested class, and these are my tested methods. Eventually, when I design a tested class, it's going to be somehow associated with a tested method. And then every of the methods inside of my test class are going to be exercising one of the methods inside of the tested class. So here is one example in JUnit 3. The difference with JUnit 3 and JUnit 4 is that in JUnit 3, you have to, all the test classes that you write, they must extend the class test class. And then instead of having @before, then you would have a method that must be named setup. Okay. And then when you write your test cases, your test methods, then they must start with test. Okay. So you see that in JUnit 3, it's much more rigid. Every test method must be, its name must begin with test. And the setup method must be named absolutely setup. So it's much more rigid in JUnit 3, but the idea is all the same. Okay. So in your JUnit 4 test class, then you can have @before. You can actually, in JUnit 4, you can have more than one @before, which you cannot have in JUnit 3. Same thing with @after, which corresponds to, in JUnit 3, corresponds to the tear down. Tear down is what would be executed after every test. For example, to release resources that were held by the execution of the test methods. So in JUnit 4, you have @before, @after, and to identify a test method, you're preceded by @test. So it doesn't have to start with test. Here it does, but it doesn't have to. This I already explained. So @before, One thing is that if you define an add before method, it must be a public void method. Same thing with add after. If you're trying to define it as a method that returns something or that is private, it's not going to accept it. Your add before classes, they must be public static void. So these are class methods. These are not object methods. And then for your every test, the class annotation is at test, and all your test methods must be also public void. If you want, after you have written all your tests, if one of the tests is annoying you and you want to ignore a certain test, then you proceed it with @ignore. Not a very good practice. Rather, what you want to do is to fix the test so that it doesn't fail anymore. But sometimes as you are currently developing and running the test, it's maybe annoying to see some tests fail. So if you want to avoid this, you can put @ignore. Maybe that raises the point as to, I was saying if you're developing, you have your tests, they are all passing, and then you're making some changes in your code, and then suddenly the tests don't pass anymore because you changed something, not necessarily because you broke something, but because you changed the way that this function is working, making it so that the test is now testing for something. It was testing for something that was there before, but the test is not compatible with how the method works now as you have changed it. So that raises the need for actually, maintaining the tests. That's one of the disadvantages of having JUnit tests, is that very often as you change the code, you may have to actually change the tests. Okay, so it increases somehow the cost of maintainability or applying changes. That's one of the disadvantages somehow of using unit testing. So finally, we come to the notion of the test suite. So essentially, a test suite is a composite of test cases. So a test suite itself is a test case. Okay. So, and it is, a test suite contains a group of test cases, so that you could have a composite or a test suite that contains other test suites that themselves contain test cases or test suites. Okay. That's the notion of a composite, for those of you who know the composite design pattern. So that's a very important notion for test suites, because you want to create somehow subsets of your test, as I explained before. If you have thousands of tests and to run, and it takes, let's say, 1 hour to run all the tests, and then in your code you make a specific change to a specific method, you don't want to have to run all the tests. You want to be able to run only a subset of the tests. To create such subsets, you create test suites. Okay. That's why test suites are important, because they allow you to test only a subset of the tests to save time. So how do you write down your or code your test suite? So if you're using JUnit 3, it's a little bit more complex than JUnit 4. So you essentially have to create a class which is the runner. And then you include a test runner. And then you include inside of your runner, you include a method suite that is returning a test. And then inside of this suite method, you actually create the test suite, which you add to the test suite. You add all your test classes that you want to be part of this test suite. So a test suite is a composition of test classes that each of them contain test cases. Okay? You can't just cherry pick some test methods inside of a class. You select one class, and then all the test methods inside of this test class are included in the test suite. So that's how you specify how you write code that defines a test suite in JUnit 3. In JUnit 4, it's a little bit less complex, though it uses these annotations here. So you have to specify what runner is being used by the test suite, which can be this one here. So that's how you specify the runner. And then you use @suite classes to actually provide the list of test classes that you want to include in the test suite. And then you write down after that the name of your test suite class. Okay. So what is it that I'm expecting you, or that we are expecting you to do in the project? So essentially, you will be asked for every deliverable, for every build, you will be asked to provide an increasingly large number of test cases. Okay. So it's going to be about how many test cases you have first. Then the marker should be looking at the test, of course, to make sure that they are relevant test cases. There will be in the statement of each of the builds, there will be some tests that are specifically stated. So you must have all of those that are specifically stated. For example, I might state 5, 6, 7, 8 specific test cases that must be there, and then tell you that you must have, for example, 20 test cases. So the specific ones must be there, and then for the remainder ones, you choose which would be the target of what is being tested. And of course, all the test cases must be relevant and valid. How do you check that? Well, the test case should be setting the context and then calling a method in a class and then doing some asserts. Okay. Which I am explaining here. So all of your test methods should actually set the context, call a method, use an assert. If any of these things is missing, it's not a test. Okay. All test cases must also be documented using Java doc. So they are classes, they must be documented. The test methods are methods, they must be documented. In terms of structure of the folders in your project, you might, for example, if you have already explained that in the previous lecture, if you have a certain structure in your code, in your source code, like say in your source directory in your folder for your project, you might have subdirectories for each of the different modules in your implementation. If you have subdirectories in your source code, you should have exactly the same subdirectories in your testing folder. So there should be a folder for source, a folder for test. For every subfolder you have in the source folder, you should have exactly the same folders and subdirectories in the test folder. So there should be a mirror image between the source folder and the test folder. And there should be also a one-to-one relationship between the classes that you have in your source code and the test classes that you have in the testing folder, the unit testing folder. And there also should be one test suite for every module or folder that you have in your source. For every test folder, you should have a test suite that will include all the tests that are effectively testing this module in your implementation. So that's about it for this lecture. Thank you.